Hello and welcome to Math with Mrs. Becker. Today we are looking at Pre-Calculus, Chapter 1, Section 5. We will be focusing on linear models and scatter plots. Many real-life situations involve finding relationships between two variables. In a typical situation, data is collected and written as a set of ordered pairs. The graph of such a set is called a scatter plot. Now, a scatter plot, what you will be doing is plotting the location for each of those ordered pairs, and you do not connect the points. Here is example 1. The data in the table shows the outstanding household credit market debt, which is D. It's in trillions of dollars from the years 1998 through 2004. Construct a scatter plot of the data. First, create a set of ordered pairs representing the data. Let T represent the year, with T equals 8 corresponding to 1998. So what that means is if T is 0, that means it's 1990. Okay, so your X value, remember when you have a table, this would be X, this would be Y. Your X value is however many years the particular year that you're looking at is past 1990. So when I go ahead and I make these ordered pairs, 1998, they're saying that should just be an 8. Then we have 6.0. 1999 would be 9 years after 1990, and it is 6.4. 2000, well, that's 10 years after 1990, and we have 7.0. 2001 is 11 years, and we have 7.6. 2002 is 12 years, and it's 8.4. 2003 would be 13 years, and the debt is 9.2, and remember that's trillions of dollars, that's terrible. 2004, it is 14 years since 1990, and the debt went up to 10.3 trillion, okay? So they want us to be able to take a table or any information and be able to first construct ordered pairs. Now they want us to make a scatter plot. Yes. Okay. So I like graphing, so this is going to be fun. So go ahead. If you look, all of our values are positive. Because all of our values are positive, it means we only need to look at quadrant 1 of the coordinate plane. We'll only be going to the right and we'll only be going upwards. Now here I don't start until 8. So remember that break symbol? You can include a little break symbol, and what that means is you are not starting at 0. Okay, without that break symbol though, you would need to include or start at 0 and then include all the numbers 1 all the way up until 8. Without the break symbol, what you would be doing is creating what's called a misleading graph. So if we want to start at 8, which is, hey, that's what I want to do, let's go ahead and start at 8. You need to have that break symbol, meaning that you are excluding values. Then I will go ahead and go 9, 10, 11, 12, 13, and 14. And these are years after 1990, because if T is 8, and that means 1998, the reason why that's 8 is because it's 8 years after 1990. So that's what the label would be here. Now, I'm going to include a break symbol here too, guys, because we're going between 6 and 10. So I'm going to go ahead and break. We're going to go 6.0, 7.0, 8.0. Not quite sure why I did the point. If you don't want to do the point, you're totally fine just going up to like 6, 7, 8, 9, 10. I think I just looked here and saw the point, so I'm like, all right, let's do a point. And this is debt in trillions. So again, you definitely want to make sure that you are labeling. So my first point, I go to the right 8, up 6.0. There's my point. The second point, I go to the right 9, up 6.4. So you're estimating where 6.4 would be. Obviously, it's in between 6 and 7, a little bit closer to the 6. 10, we're up to that 7. 11, I'm up 7.6. Holy smokes. 12, 8.4. 13, 9.2. Look at that debt soar. 14, 10.3. That, my friends, is a scatter plot. It is just a group of coordinates on a coordinate plane that you do not connect. So there is the first example for 1.5. Can you take a table, create a set of ordered pairs? Lots of times they're going to give you a little scenario here that helps you with that ordered pair. So you want to make sure that you read all of the directions in case it alters. Like here, it would have been wrong if you put 1998, 1999, because they told you if it's 1998 to make sure you do an 8. So always make sure that you read the full directions. But again, first goal, table to ordered pairs to scatter plot. Make sure you label your graph. Let's keep on trucking. Consider a collection of ordered pairs in the form x and y. If y tends to increase as x increases, so that means as x is getting larger, so as you go to the right, your y values also increase. So as you go to the right, the y values are going upwards. The collection is said to have a positive correlation, and that's what that would look like. As you are going to the right, the graph tends to go upwards. If y on the y-axis, if y tends to decrease as x increases, so that means as x increases, as you go to the right, the y values tend to decrease. That is called a negative correlation, okay? If it doesn't do either, if it's just a bunch of random dots everywhere where you cannot tell, is this going upwards, is this going downwards, that is said to have no correlation at all. It is neither positive nor negative. So looking back at our example 1, this would be a positive correlation because as the x values were increasing, as we were going to the right, the y values, their pattern, it tended to go upwards. So this would be an example of a positive correlation. And so what that actually means is as the years go on, okay, so as time passes, the amount of household credit debt is increasing over time. Okay, let's look at another example. On a Friday, 22 students in a class were asked to record the number of hours they spent studying for a test on Monday. So what this means is how many hours they spent studying over the weekend, okay? And the number of hours that they spent watching TV. So during the weekend, how many hours did you spend watching TV versus how many hours did you spend studying for the test that would occur on Monday? The results are shown below. The first coordinate is the number of hours, and the second coordinate is the score obtained on the test. Create a scatter plot for each data and then determine the correlation and what that actually means. Okay, so we're going to have two different graphs here. I'm going to use some graph paper. So study hours. The x value is how many hours they spent studying. The y value is what their score was on the test. So I'm going to go ahead and say, okay, we're looking at study hours versus test score. Again, everything is positive because you can't have a negative test score and you can't study a negative amount of hours. So if I look at study hours, if I'm looking at the x's, the largest value that I see is a 10. So that's the x. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are study hours. Okay, that's our x value. Now the score, the highest score I see is a 98. The lowest is a 40. So I'm going to go ahead and do a break symbol. And I'm going to start at 30. So 30%, 40%, 50%, 60%, 70%, 80%, 90%, 100%. This is the test score. Okay, so let's go ahead and plot these ordered pairs. So 0 was at 40. So that person studied 0 hours. They ended up with a 40 on the test. Got it. Studied 1 hour, got a 41. Okay, I would be sad if I studied a whole hour and got a 41. 2, 51. 3 hours, 58. Wow, this test must be really difficult. 3 hours and a 49. Bummer, dude. 4 hours and a 48? Yikes, I wonder what this test was on. 4 hours and a 64. Hey, we got a passing score, you guys. 5 hours and a 55. 5 hours. Oh, here we go. A 69. It's still not even a C. 5 hours studying. And this person only got a 58. 5 hours studying and a 75. Lots of people study for 5 hours. But imagine if you studied for 5 hours and you got like a 55 or a 58. Oh my goodness. 6 hours and a 68. 6 hours and a 63. 6 hours. Oh, nice. I was starting to wonder if anybody was going to get an A on this test. 6 hours and 93. 7 hours, 84. 7 hours, 67. 8 hours, that person scored a 90. 8 hours, a 76. 9 hours, a 95. 9 hours, a 72. 9 hours, and 85. 10 hours, that person scored a 98. Okay, so here is a scatter plot, and what you're doing is you are looking at the amount of study time compared to the test score. Now, your correlation here, I notice that this is a positive correlation, okay, because the dots tend to go upwards. And so what that means, as X increases, so as your studying time increases, the Y value also increases. So what you could say, because this is a positive correlation, as you spend more time studying, your test scores will tend to also increase. The more you study, the better your test scores will be. Positive correlation. Now let's go ahead and check out what happens if you watch so much TV. Okay, so I'm going to flip my paper upside down and let's do this set. So we are looking at TV hours versus test score. Okay, so again, I only need to look at the first quadrant because everything's going to be positive here, okay? If I'm looking at TV hours, that is the X value, so that's what goes side to side on my X axis. 0 is the smallest that I see. Holy smokes, somebody watched 20 hours of TV. That's nuts. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I hope you guys are doing this with me. 11, 12, 13, 14. Because of our TV bug, I didn't even have my graph large enough. 15, 16, 17, 18, 19, 20. There must have been like a marathon on of like that person's favorite like Netflix show or something. Something crazy. Okay, now score on the test. The highest again I see is a 98. Oh, you guys, this time 40s. Okay, I saw the 19 and 20, and for a minute I forgot that that was the hours of TV. I thought that was the test score. I was thinking, holy smokes, that's terrible. We're going to go ahead and get and do the break symbol. So our first one, we can start at 30%, then go 40%, 50%, 60, 70, 80, 90, and 100. This is test score. That's what that represents. This is hours watching the tube. Okay, so let's go ahead and graph them. 0. If this person watched 0 TV and scored a 98% of the test. 1 hour watching TV, scored an 85. 2 hours watching TV, 72. 2 hours, that person scored a 90. 3 hours, 67. 3 hours, 93. Awesome job. 3 hours, 95. 4 hours, 68. 4 hours, 84. 5 hours, 76. 5 hours, 75. Let's go right underneath that 76. Oh, my bad. Okay, 5 hours, 76. That one is not there. 7 hours was our 75. There we go. 7 hours, 58. 9 hours watching TV. Well, just, I guess, for a whole weekend. It's kind of a lot, but maybe they got into some movies or watched a movie series. 9 hours got a 63. 9 hours got a 69. 11 hours got a 55. Oh, the scores are really going down here. 12 hours got a 58. 14 hours got a 64. At least they passed. 16 hours got a 48. Ooh, we're dropping down below that 50. 17 hours of TV. 51. 18 hours, they got a 41. 19 hours, they got a 49. Oh, this is so sad. I would cry. Wouldn't you guys cry? 20 hours, that poor soul got a 40 on the test. Okay, and again, I had a little boo-boo there, so I crossed that one off. But if you look at the dots here, what they want you to figure out is what kind of correlation we have. Well, as I go to the right, the dots do tend to go downwards. Remember, it doesn't have to be in a straight line, but you can tell that they do tend to drop. So this is an example of a negative correlation. And what that means is as X gets larger, as you are watching more TV, the Y value gets smaller. So as you watch more TV, your test scores tend to drop. Because notice that does kind of follow that line. And this line is kind of where we're going next. We're going to talk about what's called a line of fit. That's why I threw that line in there, just to kind of get you thinking about what's to come. But again, negative correlation, as the X value gets bigger, the Y value gets smaller. And in this situation, if you are watching more TV, the trend is that your test score will drop as that TV time increases. Let's look at the back side. Finding a linear model to represent the relationship described by a scatter plot, it is called finding or fitting a line to data, or finding a line of fit. You can do this graphically by simply sketching the line that appears to fit the points. Now again, notice it says that you are sketching your own line. The cool thing here is that every single person in this class, we could all sketch a line of fit, and we can all have a correct line of fit, but our lines may all be a little bit different because we are sketching a line that we feel best fits the data, okay? So again, to do this graphically, simply sketch a line that appears to fit the points. Find 2 points that are on the line, then you need to find the equation of a line that passes through the 2 points. So that is what we were just studying. If you have 2 points on your line, you take the 2 points. If you want to find an equation, step 1, you have to find the slope. Once you have the slope, you use the slope in one of those 2 points to go into point slope form, then convert it to y equals mx plus b. Okay, find a linear model that relates the year to the outstanding household credit from example 1. Identify the correlation, if any exists, sketch a line, and then find the equation. So here we go. We're actually going to go back to here. Now this one was pretty linear, so I probably didn't pick the best equation, but what you're going to do is try to probably didn't pick the best graph. You are going to try to find a line that you feel best fits the data. Your goal is to have the same amount of points on each side of the line. So like if I move my ruler around, I could see here I'd have a couple points above the line, a couple points below the line. Your goal again would be to have a few points that are on the line, so that way you can find the equation of a line. So draw a line that you feel best fits the data. I'm gonna do a red one here. Okay. That has way too many. The reason why I went, and I'm going to change it, because your goal is to have the same amount of points on either side. On this side, I really only have 2. This side I have, this is pretty much on that side, 1, 2, 3, 4. So it's not really a good line. You can always go ahead and change your line a little bit. I'm going to do, that looks like a pretty good line. Let's do that. Okay. Just got to make sure I graph this. I want to get a few lines on. Okay, here we go. We're just going to go with it. I hope your line making skills were better than mine. So I'm going to actually go with my first one because I feel like that was a better line of fit. So you draw a line. Your goal is to have the same amount of points on either side. So here is my line. You pick 2 points that are on your line. So if I'm looking at my line that I made in the black pen here, this point touches, this point touches. So the next step, okay, we already said that this is a positive correlation because as we go to the right, the value is going up. As time increases, so does the household debt. You draw a line that you feel best fits the data. Okay, and again, as long as you draw your line, it does not have to be the same as mine. It doesn't have to be the same as anybody else's in the class. You are drawing a line through the data. From your line, you pick 2 ordered pairs that touch the line. Mine that touches is the 9. So I have 9 and 6.4. The other one is the one that happened on 13 years after 1990, so 2003. So the ordered pair is 13 and 9.2. Okay, so I drew a line. We figured out it was positive correlation. So let's flip back and see what they want me to do. Identify correlation. We said it's positive. What does it mean? As time goes on, you have more household debt. Sketch a line that you feel fits the data. Okay, again, I had a hard time, but guess what? It's still going to be all good because the line goes through the points and I have 2 ordered pairs. Select 2 ordered pairs from your line. I had 9 and 6.4 and 13 and 9.2. Now you find the equation of the line. Step 1, to find your slope. Remember, this is x1, y1. This is x2, y2. So I take the second y, 9.2, minus the first y, 6.4, over the second x, 13, minus the first x, 9. So if I take 9.2 minus 6.4, it's 2.8. 13 minus 9 is 4. Okay, we do not want to leave it so we have a decimal within a fraction. So I'm going to take 2.8 divided by 4, and I get 0.7. Now you pick 1 ordered pair. I'm just going to pick the first ordered pair. It does not matter which ordered pair you select. You would get the same equation of a line either way. Okay, so I'm doing the first ordered pair. There's my slope. Y minus the y from the ordered pair I chose, so 6.4, equals m, 0.7. X minus the x from the ordered pair I selected. That's called point slope form. This is our transition equation. We want to go ahead and turn that into slope intercept. So I distribute my 0.7. Y minus 6.4 equals 0.7x. 0.7 times 9 is a negative 6.3. So I have my minus here. 0.7 times 9 is 6.3. If I want y by itself, I need to add the 6.4 to the other side. So y equals 0.7x plus 0.1. This is the equation of the line that I drew, the black pen line. That's the equation of the line that I drew through the points. And you guys, that is 1.5. So you do have a worksheet to complete. Tomorrow is a work day to complete that worksheet in class. That way, if you have questions, I am here to help you out. If you are a distance learner, go ahead. The worksheet is in the Google Classroom right along with this video. And if you have any questions, just send me an email and I'll help you out. Take care.